Okay, today's lesson we're going to look at solving radical equations. So before we get to that, let's just quickly review how to solve a regular equation. So when you would have done these before, remember the goal is to isolate x. You want to get x by itself, and in order to do that you have to move things around in the equation by doing the opposite. So for this first one, let's bring the 3x over to the left side. So we do the opposite, so we subtract the 3x. So that would give us 2x plus 1 equal to 8. So then the next step is let's get rid of that 1. So we'd subtract 1 on both sides. So we'd have 2x equal to 7. And then our last step is divide by 2. So our final answer then would be x equals 7/2, or we could do it as a decimal, 3.5. Okay, so that means then if we took that 3.5 and plugged it back in the original, both sides of the equation would be the exact same. So when we're solving radical equations, they're going to look very similar, except there's going to be a square root involved. So if we do this example first, you can see we have a square root in the equation. So what we need to do in order to solve these, just like before, we want to isolate the x, but before we do that, we need to get the square root by itself on one side of the equation. So in this case, we have the square root already by itself, the square root of x plus 5, so it is isolated. So once that's done, the next step then is to get rid of that square root, and we do that by doing the opposite. And the opposite of square rooting would be squaring. So we just square both sides, and when you square and square root, those cancel out, so we would just get x plus 5. And 2 squared is 4. So now to solve it, subtract 5 on both sides, just like we did before. So our final answer is x equals -1. So when you're doing radical equations, the only thing you want to do at the end is double check to make sure that it works. So if we put -1, let's just go back to the original. If we put -1 into the root, so -1 plus 5 is the square root of 4. Square root of 4 is 2, so 2 equals 2. It's good, so that means, right, we get both sides of the equation sign being the same, so that means x equals -1 is a valid answer. In the case that it wouldn't work, and that will happen sometimes, then we say it is an extraneous root, which just means it's an answer, but it actually doesn't work into the equation. So let's try another one, a little bit harder. So if I give you 3 times x minus 2 under the root plus 4 equal to 13. So when we solve this, what we want to do is the same thing. We want to get the x by itself, but before that, we got to get the root by itself. So we'll get rid of the 4 first. So we have 3 times x minus 2 in the root equal to 9. Now we want to get rid of that 3. So divide both sides by 3. So then we get root x minus 2 equal to 3. Now we've isolated the square root. We're ready to get rid of the root sign. So square both sides. So we have x minus 2 equal to 9. So our last step is move the 2 over. So our final answer is x equals 11. And once again, plug the 11 back in the original, so you'd have the correct answer. Okay, so let's try one more. So this one's going to be a little bit harder. It looks the same kind of question, but the problem with this case is we end up getting a squared in the equation. So when we do the same thing, we want to get rid of the 4 first, get that square root by itself. So subtract 4 on both sides. So we'd have n minus 4 equals square root of 2n minus 8. So now when we square both sides, this is where you run into the problem. So we square the square root, that's good, but now when we square this side, we have to square the whole thing. So we end up getting on that side, we have n minus 4 times n minus 4. So if we FOIL that out, we have n squared minus 4n plus 16. And we can simplify that to minus 8n plus 16. So that's what the whole left side is going to equal to. And on the right side, we just get a 2n minus 8. So because we have a quadratic, we have an n squared in there. What we have to do is we now have to make it equal to 0. So bring the 2n over. So we'd have n squared minus 10n minus 16 equals negative 8. So our last step is get rid of the 8. Okay, so we should get n squared minus 10n, that was plus 8, so we have minus 8 equal to 0. So in any of these kind of cases, if you end up getting a squared, in this case we have an n squared, then we have a quadratic, so in order to solve this, we actually have to solve this by either factoring, by graphing, using a solver. We have to use some sort of method in order to get those answers. And in this case, I think we get decimals. If we try factoring it, we'd have 4 and 2, that doesn't work, 8 and 1 doesn't work. So we run into a bit of a problem with these n squared. So the good news is you won't get many of these, but you do have to know how to solve them. Let's try another one. So let's look at 2 times square root of x plus 5 equals negative 6. Looks like an easy one. And it is. So the only trick to it is when you solve it, we divide by 2. So we'll get root x plus 5 equal to negative 3. Now we want to square both sides. So when we square the negative 3, we got to be careful because we'd actually get negative 3 times negative 3 is 9, so we'd have x plus 5 on this side equal to 9, and we subtract our 5, and we're done. So minus the 5 on both sides, we get x equals 4. So 4 works, looks like it works out properly, but let's go back and plug it in. So if we go 2 times 4 plus 5 equals negative 6, so 4 plus 5 is square root of 9, which is 3, so 2 times 3 is 6. Is 6 equal to negative 6? No. So because it doesn't work, even though mathematically we got an answer of 4, it doesn't work when we plug it back into the equation. So what we do in that case is we say there's no solution. And the reason for that is because x equals 4 was an extraneous answer. So it's important to make sure you double check just to see if there actually is an answer or not. So in this case there wasn't one, so we just say there's no solution to the question. And we'll stop there.